Namaste everyone. In today's video, we shall answer a question from Science CFPQ, that is competency focused practice questions. I've already made a video on CFPQ, competency focused practice question. In that video, I have told you how to download these questions CFPQ from the CBSE website. You may please look into that video. It is available in my channel Vinayaka AV. Before we solve this problem or answer this question, I have a request. So if you want to get online tutored by me individually or in groups, you may please contact this number 9742774659, either through phone call or WhatsApp. This is only for online tutoring, individual or in groups. Thank you. Now let's go back to the question. So Suresh, a person by name Suresh, he bought a packet of 100 LEDs. So on the packet there was a label which was written like this: LED2835. That's the type of LED here. 0.2 W, here W is watts. That tells that the power rating of each LED is 0.2 watts. How do we know it is power? Watt is the SI unit of power, you know that, and lumens is the SI unit of intensity of light. It tells that how brightly the LEDs glow. And V, here V stands for volts, and volts is the SI unit of potential difference. So what is given? Voltage or potential difference across each LED is given, that is 3 volts. So he wanted to use these LEDs for decoration purpose. So he referred to website to know how these lights or the LED should be connected so that they can be used for decoration. In the website it was given that the LEDs for decoration purpose should be connected in this way. This is a diagram showing how the LEDs must be connected. Now there are 5 questions following this. The first question, they ask which of the following describes how the LEDs are connected in the circuit diagram. If you look at the diagram carefully, so suppose if I take a current I here, this current will flow through this LED1, the same current will flow through LED2, and the same current will flow through all the LEDs up to LED8. Now if you observe carefully, there is no other path other than this path for the current to flow. So the same current, that is I, will flow through LED16, LED15, so on up to LED9, and then it goes back to the main supply. So through all the LEDs, same current is flowing. We know that current remains constant whenever the devices or resistors are connected in series. Based on that, we can answer the first question, which says that which of the following describes how LEDs are connected. So all the LEDs, all the 16 LEDs in this figure are connected in series. So the correct option is all in series. Now let's look at the second question. If the LED marked LED2 in the diagram stops working, which other LEDs will also stop working? What do you mean by LED stops working or any device stops working? That device will not allow any current to flow through it. That current will block or not allow any current to flow through it. Here LED2 has stopped working due to some reason, and that means this LED will not permit any current to flow through it. Now which other LEDs will stop working? If LED2 doesn't work, we need to say which of the other LEDs will not work. So we know that as all these LEDs are connected in series, and because of this damaged LED2 or the LED2 which is not working, this is like open circuit here. This is like open circuit, and we know that current flows only in a closed path, and because LED2 is not working, the path through which current is supposed to flow is not a closed path, it's an open path. Therefore no current flows through any of the other LEDs which are connected in series with this LED2. So now the question is which other LEDs will also stop working? In fact, all the LEDs which are connected in series with LED2 will stop working. So what is the correct option? All the other LEDs in the circuit. So this is the answer to the question, which other LEDs will stop working. Now let's look at the third question. In the third question, so Suresh has decided to connect all the LEDs in his lights in series combination. How many LEDs will he need to connect if he's going to connect the LEDs to a 240 volt main supply, so that the LEDs work at their power rating? So as per the question, the power rating is 0.2 watts and all the LEDs should work at 3 volts. So we need to identify the number of LEDs that need to be connected. Now let's go back to the figure that is given in the question. Let's assume the potential difference across LED 1 is V1, LED 2 is V2, LED 3 is V3, LED so on. The potential difference across LED 8 is V8. So, or in general, if you connect the LEDs in series, as per the question, we don't know how many LEDs he is supposed to connect. In fact, we are supposed to find the number of LEDs. Let us assume Suresh has connected n number of LEDs. Let the number of LEDs connected in series be n. Now let's assume the potential difference across the first LED is V2, the potential difference across the second LED is V2, and the potential difference across the nth LED as Vn. As per the question, all the LEDs are supposed to be operated at 3 volts. From this we understand that V1 is equal to Vn, V2 is equal to so on up to Vn is equal to 3 volts. V is equal to 3 volts. Now what they should be connected to which supply? A 240 volts supply, like this. Now this circuit symbol is generally used for an AC supply, so alternating current supply. More about this you will learn in the next chapter, or the chapter called magnetic effects of electric current. As of now, you just can note that this is the circuit symbol of an AC supply. So, and let's assume that the potential difference or the voltage of the given supply as V, and it is equal to 240 volts. So whenever these devices are connected in series, we can write V is equal to V1 plus V2 so on up to Vn. Now V is equal to, so this is 3 volts, when V2 is 3 volts, so on up to 3 volts. If there are 2 3s, we'll write 2 into 3. If there are 3 3s, we'll write 3 into 3. If there are 4 3s, we'll write 4 into 3. Similarly, now here there are n 3s, so V will be equal to n into 3, n into 3. Why? Because we have assumed the number of LEDs that are connected by in series by Suresh as n. So V value is 240, n value is what we need to find out. So we can write n as 240 by 3, n as 240 by 3, so n is equal to 80. So Suresh should connect how many LEDs? So Suresh should connect 80 LEDs. 80 LEDs. He is going to connect 80 LEDs to a 240 volt main supply. So which is the correct option? Option 2 is correct. Now fourth question. In the fourth question, what will happen if he connects 100 LEDs all in parallel combination to a 240 volt main supply? First let us draw a circuit diagram showing how this 100 LEDs can be connected in parallel. So this is the first LED, that is LED 1. Now the second LED, I shall label it as LED 2. Like this, we have how many LEDs? As per the question, 100 LEDs. So the 100th LED, let me label it as LED 100. Now they are supposed to be connected in parallel like this, and they are supposed to be connected to a 240 volt supply. 240 volt supply. Now we know that in parallel potential difference V remains constant. V remains constant. Whenever two or more devices are connected in parallel, the potential difference across each of them remains constant. So the potential difference across the 100 LEDs should be same. And how much is that? So it will be equal to 240 volts. How can we say it is 240 volts? Here, there through the connecting wires, as you know, these are the connecting wires. Across the connecting wires, the potential difference drop or voltage drop is negligible. So the 240 volts voltage of the power supply will appear across each of these LEDs. So each of the LEDs will get a potential difference of 240 volts. Now, what is the recommended value of potential difference or voltage across each LED? It is 3 volts, but here they are getting 240 volts. They're getting much more than the recommended value. So this very high value of potential difference across each LED will allow more current to flow through each of these LEDs, and it will damage the LEDs. Now let's look into the options and check whether we have we have an option saying whether the LEDs will get damaged or not. As you can see, option 2, each LED will have a potential difference of 240 volts and therefore they will get damaged. So therefore option 2 is the correct answer for question 4. Now let's look at question 5. How much current is each LED expected to draw when you used according to the ratings in the label? Again, going back to the label and the ratings in the label. So power rating is 0.2 watts and the potential difference is 3 watts. So now they're asking how much current, they're asking the value of current. So that is question 5. Now power rating is 0.2 watts, potential difference is 3 volts. We need to find out what is the current. So to find the current, we should think of a formula wherein all these three are present, or where all these three, that is P, V and I, are related. We know P is equal to Vi. We know P is equal to Vi. So P value is 0.2, V value is 3 and I value is what we need to find out. So this will be 0.2 by 3. If you divide 0.2 by 3, you'll get the answer as 0.066, so on, non-terminating repeating decimal expansion. So which we can round off and say the current is 0.067 amperes. 0.067 amperes. So how much current is supposed to flow through each LED as per the given ratings? It is 0.06 amperes. Now let us check whether 0.06 amperes is there in the option or not, in the given options or not. And as you can see, in the first option we have 0.067 amperes, and therefore option 1 is the correct option for question 5. I hope you have understood how to answer these questions. Thank you for watching. Please subscribe, like and share. Thank you again.